Hmm? It should be all the same. We got it off the canvas.
No, I mean like for the core.
So there are different ways to do it, and you can figure out which one is the one first, based on the ratio. Yeah. That's
Yeah, I think this one's supposed to be B.
right. So there's really no set of ways.
Something like that.
Solve the problem as long as you know.
We'll see.
So
Where you're
whatever.
focused.
So as long as you end up with my
Yeah, I had issues.
and
I didn't get there yet.
This is what I wanted to add.
Okay. Well,
I didn't get to this one yet.
This is what I want to add.
so X and Y is
Because
basically
you know, like all the
If you have-
examples you gave were just like elements. It's like a
Oh.
whole component.
Just write out. Alright, so what I think we should do is just like
Because
write
I
out
found
the
noise for each of them, for the
Mhm.
water and the element.
Yeah.
And I'm like, so how do I get
So you just put it in the simplest form, I
Write out
think,
the-
after you figure out the amount of moles.
then
how do you put it in?
So wait, do you remember what the amount of moles and stuff was?
just write out the equation and then try to solve it from there.
yeah.
That's what I would do.
Okay.
Okay. This is the one.
Okay, so then I believe you divide all of them by the smallest amount of moles.
I did that.
Yeah,
I
to get
think
the
I
small,
had.
to get the
Can
whole
you do
numbers.
that?
Sure.
All right, we are gonna take a quantum leap from this point on, trying to understand what we talked about since the beginning of the semester. Now, we've been looking at atoms and molecules and how they react with one another. Now, how do we know, since we cannot see molecules or atoms, and they're so tiny, they're so small, how do you know what we're proposing is correct? What determines the properties of those chemicals there? So we are going to look into chapter 7 there in the quantum mechanical model, trying to understand the structure of atoms. Now we know in chapter 2, we started chapter 2 with the subatomic particles in an atom. In any given atom, there are a certain number of protons, certain number of neutrons, a certain number of electrons. If you have hydrogen, well, hydrogen has one proton. Hydrogen has one electron. Okay, so we have that proposed structure of the atom. We have the positively charged center, and the electron is circulating around that positively charged center. Helium, you get 2 protons, 2 neutrons, and 2 electrons. Okay. So we say, well, those 2 electrons are circulating around the positive charge center. But what's the relationship between those 2 electrons? Are they moving in pairs, circulating around the positive charge center, or they have their different orbitals, just like the solar system? And you have the sun in the center, Mercury, Jupiter, and Earth, and Mars circulating around the sun. What's the relationship when you have more than one electron? So that's what we're looking at. How are the electrons, what is the basic structure of an atom there? When you have more than one electron, how are those electrons being distributed? Why is this important? Because understanding the distribution of electrons, we will be able to understand. We will be able to understand how does each element, atoms of each element behave, or why they behave the way they behave. And the electron distribution has everything to do with the chemical and physical property of the elements that we know of. And then the electron distribution within a molecule determines the property of that kind of molecule, of the molecule there. So we do need to understand, and all of the things that we have talked about so far. Okay. Metals loses electron, non-metals gain electron. Why? How do you know that? Well, this is the theory that actually deals with this. Okay. So the quantum mechanical model, basically we're looking through the quantum theory, trying to understand the basic structure of atom. Once you understand the basic structure of atom, once you understand how the electrons are being distributed, you will be able to understand, okay, this is the element that has this kind of electron distribution. It's going to behave like this. Metals loses electron. And another kind of elements, well, they have a different types of electron distribution. As a result, they will behave differently. Non-metal, they are going to gain electrons. Okay, so this is really the fundamental reason how and why atoms behave the way they are. So in order to understand chemistry, it's very important that we understand the basics of quantum mechanics. Now, quantum mechanics is at least in chemistry major, it's a one-year course. You have 2 semesters of quantum mechanics there, and that's beyond the scope of this particular course. So we're not going to get into the details about the calculation involved in quantum mechanics there. We're not going to get involved in how do we figure out the different states and the electron spin and all that. We're only trying to introduce, this is how we understand the basic structure of atom. Based on that understanding, we end up with our understanding of the current world based on our knowledge there and the current knowledge of chemistry there. And while we cannot see atoms, we cannot see molecules, they're so small, but based on this theory, we make our prediction. The prediction actually matches what we observed in the laboratory, and which proves the proposed theory is actually correct. So this is when you first started taking chemistry classes there, and your instructor will say, well, molecules are like this and atoms are like this, and you always have that question in the back of your mind. How do you know? You can't see them. Okay, well, we can't see a single atom, we can't see a single molecule, but we can see the behavior of a large collection of molecules and atoms. And if your theory about the molecular structure, atom structure is correct, then one individual will behave the way that you predicted. A large collection of those individuals, the same type of atoms or molecules, will also behave the same way. So we cannot see a single atom or molecule, but we can see a large collection of the same kind of molecules and atoms there. And if they behave the same way that the theory predicts, we say, well, we have experimental proof that the theory is correct. So the beginning of quantum mechanics, and this is a very important chapter in human history, how we understand everything that works in this world. And all of these happened at the turn of last century. We're not talking about 1999, we're talking about 1899, somewhere around the turn of the 1900s there. So until the beginning of the 20th century, it was believed that all physical phenomena were deterministic. And you can actually determine classical physics, Newton's physics law. You can actually determine for a moving object, if you know how fast it's moving at this moment, you can predict how fast it's going to move the next moment. Okay? And you can measure the position, you can measure the velocity of that moving object with certainty. Well, when you get into microscopic world, when things get much, much smaller, well, things are no longer what we call deterministic. For a moving electron, if you know how fast it's moving, you may not be able to pinpoint where it is. If you know where it